Okay, so I give an introduction to data structures in the class that I teach. In this introduction to data structures, I give some exposure to basic vocabulary. So I come up with a decent definition of data structure. I talk about file formats. File formats such as this JSON and XML are examples of ways that you can structure data for the reading of that data by using a particular program. So you could just open this in a text editor, both of these little snippets of files here. This is weather data. Sometimes certain software will enable you to visualize data of this sort as a sort of a tree data structure. But I'm just trying to get people into the headspace of thinking about why certain data things called data structures might be needed. What is an order that makes sense to store weather data in? For example, is certain data more important than other data? Should this little icon, which is from Weather API website, I think I copied this from Open Weather API, something, this website. Is this icon as important as the temperature? Should it be buried more deeply inside? Should it be indented, more levels of indentation in this data that we're looking at? So I give many examples of these typical data structures, and we're going to write classes for most of these classes in C++ that define the member variables and the member functions that might logically exist for each of these classes, or we'll use the standard C++ libraries implementation of these data structures and write some programs with them. The queue, for instance, will write a grocery store simulator using a queue data structure. But regarding this bit of vocabulary, we can subdivide data structures into data structures that are linear and non-linear. Again, I don't intend to read these slides in these videos so much, but there's also some additional words that you can just use to describe data structures. Are they static? Are they homogeneous? What do these words mean? You can read those definitions that I put there. And I give a basic overview of those data structures that I listed in this slide here. Eventually, yeah, this slide. So a basic overview of these is what comes later in these slides. C++ has built in into the standard library. It has a linked list, a couple of different linked lists, a singly linked list and a doubly linked list. It has stacks, it has queues. It has trees in a way. It definitely has the map data structure. We'll see what I meant by the tree business later. And graphs, I've yet to poke into that significantly, but there's potentially support for graphs as well in the C++ standard library. We'll see. But so arrays, we know what arrays are almost certainly, regardless of who is watching this video. The simplest type, in a way, the simplest type of array declaration is done by using some syntax like this: list of nums. This is a static raw C-style array. List of nums 5, and consisting of 5 elements. Maybe we say list of nums equals 1, 2, 3, 4, 66. Okay. So this, yeah, I've gone out of bounds here. That's kind of a surprising error. It has to do with some of the subtleties that are involved in what I just did, but this is it's pretty intuitive. Um, See out list of nums at position 0 is going to print 1. And we could iterate through that list and print all of the numbers that are in the array. Okay, so the 0th element is 1. What happens if we attempt to print the 6th position? There is no 6th position or 7th position here. 1, 2, 3, 4, 5, and there is this is not allowed. It's not allowed in the previous case because I passed in the wrong data type, or that was that was not a variable that I typed. So 77, too many initializer values. So that's one little limitation of this array. This thing I'm calling a C style array or a raw array. Okay, so what happens if I attempt to do this? I'm trying to illustrate some of the limitations of this. So it prints some garbage. It does, and there is a warning that's generated. I apologize about the background talking if you can hear that. Just people walking past in the hallway. Okay, index 6 is out of the valid index range. There's a better alternative to this. Maybe you think this is fine, but there is something in the standard library and the standard include files called array. All right, so we can pound include array, and it's different from this. If we say, at this point, I like to start using prefixes. So I like to say standard array in my main program. But I'm just going to add those aliases up here. So if instead of this, we say standard array, an array an array is template based. So notice we have 2 flavors here, type name, and then this unsigned 64-bit integer, something like this. C++ gets into, and C get into a lot of wonderful complexities regarding integer types. There's something called size T, which is eventually worth being aware of. Okay, so a type name, as in an integer in this case. The size T, the size of the array, 5 elements. List of nums prime. Okay. And can we use this syntax here? Let's change these numbers. -4, 5, 3, 99, 21. Okay. Just because 1, 2, 3, 4 seems, I don't know, it seems there's potential for confusion here. So I'm curious how this standard array, which is, I'm going to make the assertion that standard array is a better version of an array to use than this C style array. This is class based. You see this array is a class. You see the tooltip there that's popping up right there, class. So what happens if I try to say cout list of nums prime at index 6, like I did there? Do I see a warning? That's not the best way to handle that in most people's opinions. To print some garbage value, that might enable you to do something like add this value to another value, and it's not the best. Let's see what happens in this case. We generate a we fail an assertion. This says array subscript out of range. This is a very aggressive way to fail. So on line 534 of this array file, which we'll go to in just a minute, says the subscript is out of range. So we just abort. That's, in a way, that might seem worse than printing a garbage value the program just terminates, but I think most would regard it as a good thing. And we also see a warning here. An interesting warning. Okay, I think it was line number 600, and might just rerun that in a minute here. Invalid array subscript. Let's rerun that. On 534, abort. Index out of range, 534. And here we are, array subscript out of range. Okay, and that is dependent on this thing called a debug level, which you can set in Visual Studio and in, I think, the C++ compiler in general. So this is an alternative. The array class has other methods, member functions. If we type dot, we see begin, data, end, reverse begin, reverse end. We'll talk about these things called iterators eventually. Assign, it sounds like it assigns a value to a particular index. We can poke into this. At is similar to the subscript operator. Back, begin, get the element at the back probably. Data, empty, it's probably, yeah, it returns a Boolean. It says whether your array is empty. End, okay, returns a thing called an iterator. I haven't looked into all these. Fill, there are many different methods here. So my intention, I thought it would be a good introduction to data structures to write our own array class. So this is a file called myarray.h, which I wrote about a year ago. I can't remember all the details of it, but this is not called array because it might conflict with this, but we just have to be careful of that. I called this my array, my implementation. So my array contains this stuff. So let me just, and I also include some documentation here. Let's, so we have syntax highlighting. Let me copy this into Visual Studio. And I'll just copy it into the same file. Not the most tidy approach, but here we go. So let me just collapse this real quick and see if we can make objects here. My array, int 5, and that's, oops, it's not standard my array, is it? Yeah. It's not within a standard namespace. Okay, you can say int, comma 5. Getting kind of silly with variable names here. List of nums, potentially. So list of nums. All right. The declaration seems to work. So what have I done in this class definition? Type name T. Again, I'll hold off on talking about trying to put in comments here. Okay, so we're using templates. So I could also create an array of characters. This is legal. I could create an array of strings. This is also legal. Right, strings are more complicated. So standard string, excuse me. Okay, I could pass in an array of strings, list of words, or list of sentences could be what's going in here. So just pointing out the usefulness of templates. The this pound include array, if we go to the document, we will see many, many instances of template, 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 template. So templates are, this is an inactive preprocessor block because I'm not using C++ version 17 right now. So let me just collapse that. But templates allow for the use of generic programming. You don't have to worry so much about your types. You can pass in, yeah. Hopefully that makes some sense. So I declare a C-style array, a static, homogeneous, array consisting of contiguous elements, and the elements occupy contiguous memory locations. They're next to one another, in other words. This is an array of type T, which is this template argument here. And we can also specify the number of elements. We're not going to get into dynamic arrays like my vector. I did cover that in my first semester teaching this class. But we could. It just gets a little bit complicated. I just wanted to use MyStaticArray as a first simple version. In fact, maybe I go ahead and specify that this is a static array. Just like this was static, the standard array is a static. It's static. It can't be resized. If you want to resize your vector, shrink it, or grow it, you need to use vector in C++. Okay, so I have some functions here. I have a static array, a C-style array, primitive raw array that lets you go out of bounds and certain bad things. Okay, and I have some member functions, get the number of elements, a bit of a silly function in this case because you pass it in as a template argument in the main function, but it may be useful. We have a print function, so this loops through the array and prints the elements. We have a get element at a particular index, and here we include an assertion. In order to use an assertion, you need to pound include assert.h or cassert. It's one of those two, the header file. So if the index is greater than 0, and it's probably nice to include an index less than, if an index is, well, we want to assert that it's either greater than or equal to 0, or that it is less than the element count. We don't want to go out of bounds. And we could make some, if we use exceptions, we could make some a more informative error message, perhaps. Okay, so we also have a modify element method. We pass in an index that we want to modify, a position, and the item that we want to modify it to. So I think this is all straightforward. In order to use this syntax, you need to do something a little bit fancy, so I won't get into that. It would be convenient, but it will, if I recall correctly, it will generate an error here if I attempt to do that. Let me just copy these numbers because coming up with random numbers is surprisingly difficult. Yeah, I can't remember if this works. Yeah, no instance of the constructor matches the argument list. So I actually did not even include a constructor function definition for this class. I'm just using C++'s built-in default constructor, which gets called whenever I write this code, this declaration here. I think it auto initializes all of the integers to 0. And if we pass in a string here, it would be auto initializing to the empty string. So maybe we say cout before, after declaring object. What are the contents? We say for int I equals 0, I less than list of nums dot, and get element count seems like a good option here. I plus plus cout list of nums dot get element at the ith position, and we see what we see. Okay, we see uninitialized values. Okay, so that's kind of unpleasant. It just has to do with the way the constructor, it was my lack of a definition of a constructor. And I think, yeah, this is generating a similar error or a related error. Okay, so let's set those. Let's use a loop and set those. We could say list of nums dot modify element at the ith position, takes an index as a first argument, and the second argument, maybe we say I times 2. And then we print the elements. So let's no longer print garbage here. So 0, 2, 4, 6, 8. Okay. And if we attempt to go out of bounds, if we attempt to say cout list of nums at index 42. Yes. So in order to use this syntax, you need to do what's called operator overloading. So let's just say get element at, in order to use the subscript operator, get element at index 42. And we only made it consist of 5 elements. So this will trigger that. It's 0. So I think maybe my logic here was backwards, so to speak. Assert that the index is greater than or equal to 0. So what happens if we try to print -2, the -2 element here? Then we trigger that assertion. Okay, in myArray.exe. And if we put that in a different, let's see. So line number 42 failed. Line number 42 right here. This assertion failed. So good to know. I think maybe I shouldn't be fooling around with this at the moment, but and index less than element count. Just to, both of those things must be true. Yeah, then we trigger this assertion because the 22 is not less than 5. Okay. Okay, so that's that, and we could call the print function. Obviously, that would be nicer than what I did here. If I'm going to define that function as a member function, I should use it. So after declaring object, list of nums dot print. Okay. We're going to fail that assertion again, but we printed the garbage values here. So we're not going to attempt to, in this simple video, we're not going to attempt to include all of the functionality of the array that is built into the standard library. Here it is, this class. It has all these methods: assign, at, back, begin, constant iterator begin, is return begin, data returns a pointer, so a pointer of type ty is the syntax they use here. Okay, we're not gonna get into all that. That's the operator overloading here. Operator, subscript operator, that's related to operator. That is operator overloading. But I think during class, when I covered this same material that I'm talking about now, I got thrown off a little bit by the use of templates, and there are some unpleasant errors that can occur when you use templates sometimes. So I just wanted to record a video lecture and post it onto YouTube where I do a bit of a better job on this MyStaticArray business. It's probably the simplest data structure to begin with, but next time we're going to talk about the stat data structure, which is probably the next simplest data structure that you encounter out of the typical data structures. Again, if we were to write a class called MyDynamicArray, that gets fairly complicated potentially. So I'm going to omit that this semester. Eventually, my video lectures will include MyDynamicArray content. But that's a decent stopping point for this video, I think.